All right, this is the black holes part 5. Um, this is one of the first pictures we have of a black hole, but you really can't see the black hole. You're like, what is this? But if you look here, the black hole is actually down there, but it's so small in there you can't see it. This is the ring of dust and gas falling into the black hole. I told you the accretion disk. This is accretion disk of material falling into this black hole. It spirals into this black hole. The black hole is at the center there, but it's so surrounded by the gas you can't see the black hole. The black hole is inside of that. But it shows that accretion disk, which is a very cool picture. All right, here it is again, a similar thing. All these, or these last two pictures anyway, are from center of galaxies, where I told you that's where we find these supermassive black holes, millions of solar masses. So this is the galaxy. It's far away, so all that fuzz there, all those are stars. They're just so far away we can't see them individually. We just see the glow from them. But when we zoom in, this is the Hubble Space Telescope picture, you can see at the center of the galaxy this dust and this disk of material, the accretion disk right here. Material is spinning into this black hole at the center of the galaxy, where the supermassive black hole is. All right, another way to find black holes is, again, I told you we look for the motion of objects around it, either falling into it or orbiting it. This is at the center of another galaxy. This is galaxy M84. This is a weird galaxy. It's a galaxy here with dust. That dark line is dust in there. We're looking right at the center. That's the center of the galaxy. Over here, what this shows is the speed of objects as they're orbiting around the center. Now it's kind of weird here. These things out here are going slow. That's in the green range. So they're going around the center of this galaxy. And these, the blue part here, means it's coming very, very fast towards us. This is going very, very fast away. And as you get right close to the center, notice this goes really high and this goes really high, which means the object at the center are orbiting super, super fast, so fast that the only thing that can keep them orbiting is this supermassive black hole at the center. And so by how fast these are orbiting and how close they are to the center, we can calculate how massive that black hole is. And this has a very, very large black hole at the center of it. All right. One of the ways that they proved, we knew this, well, we theorized that it existed and we had a pretty good idea from radio work, but these guys at UCLA did a study starting back in the 1990s, but they used the biggest telescope in the world, the Keck telescope. Right over here, see if this works out. Here we're going to view this full screen. And they started to watch these stars. All these are stars. These are stars right at the center of the Milky Way galaxy. And so in 1995, they started using the biggest, best telescope in the world, the Keck telescope, which is in Hawaii. And they watched these stars for many, many years to see how they moved. And then once they moved, they could calculate their orbits. And once they calculated their orbits, they could figure out what was there. So this was them watching these stars, and they put these trails here showing the orbits of the stars. Now it should be smooth, but my internet connection is a little slow here. But these are orbiting around, and if you see, hopefully it'll kick in here in a second, they're all orbiting around this object at the center of the Milky Way. And that's how they can calculate how massive it is. That's how we know it's about 3 point something million solar masses, because these stars are going around very quickly. Within 5 years they have moved this far, which is a very large distance. Alright, it doesn't seem like it's working. The internet's kind of kicking out. So you're going to have to watch that one on your own. Click on that when you get the PowerPoint. Go to the regular PowerPoint, not the one with narration, and you can click that link as well. Alright. Now I was talking to you about the photon sphere and how we can detect black holes if they were close to us. So you see, this is a computer simulation. What it'd be like if a black hole flew by right by you. Now what you're looking at here is this area right around here. This is the photon sphere, this kind of glowing region around it. But the stuff you look at, like these galaxies you see here, are actually not there because of distortion. Those are galaxies that are like way over here. It's light bending around the back of it. And all the light, all of the sky, even everything behind the black hole can be seen in this warp layer right around the edge. So you can see the whole sky. It's just very distorted, but it is all there. And you could look for that distortion of light, and that distortion of light tells you there's a black hole there. All right, the movie Interstellar. If you haven't seen it, you should see the movie Interstellar, but it's all about black holes. Now I'm going to give you a little part of it here, and I'm going to give you a spoiler if you haven't seen it. So this is the way it works here. Hopefully my internet connection will work good enough to see this. So we're going to try again over here. Let me skip the ads. See if we can go full screen. Alright, so the premise is here that Matthew McConaughey and these astronauts are looking to save Earth that has this blight that's destroying the Earth. And they sent out these people to these black holes, or to these stars that were around black holes. And there's a black hole out by Saturn that creates a wormhole that they can jump through and get to these places. So they're checking out, they're going to this moon to find the wreckage of one of the people that they had sent out before, to figure out if this was a place people could go habitate. Now this planet that they're on is very close to the black hole. The black hole is called Gargantua. And because it's close to the black hole, they are doing a very huge time dilation. So like he was saying, an hour here is 7 years on Earth. So because they're close to the black hole, their time reference is totally different. Okay, very good, nice and scientifically accurate on that part. And because they're close to the black hole, I told you can create these giant tidal patterns where you get tides. Well, here you have huge tides that can move the water around the surface if there was a water surface close to this. Now physically this is probably not possible, but the idea is very cool. Alright, so they're finding the wreckage from this ship, a previous ship that came many years before, but it wasn't that many years before because the time for these people on this planet wouldn't have been as fast, so it's kind of relative to be what their time was. So this could have just wrecked a few hours before, depending on what their time reference is, which could have been 40 years later for the Earth. Alright, because of the tides, there's this giant tidal wave that forms regularly coming around the whole planet. And that's what they're seeing on the horizon, is that is a wave of water.
Brad, going back to the Ranger now.
We're not leaving without data.
Back here now. We do not have time. The second wave is coming. We're in the middle of the swell. Get your ass back to the Ranger now. Brad, get back here now. Please, we're good. Yeah, Brad. Go, go, go. Yes, you are. Yes, you are. Come on, face us, get back here, boy. Come on. Relax. Go, go, go. Into the overriding inside hatch. Engines are flooded. Grab your
Alright, pretty intense, but fairly accurate and cool. If you haven't seen the movie, you should see the movie. It's got a lot to do with black holes. All right, back to here. This is what they're talking about here with what was going on in the show. So this Gargantua is the black hole in the movie Interstellar, and so they're plotting it relative to what we would see on the Earth in the solar system. So this black hole is almost as big as Earth's orbit, so it's a huge black hole, one of the biggest ones in the whole universe. But the distortion of the light around it, which is what they show in the movie, is very accurate, and the time dilation is accurate here, where if you get to a certain position here, 1 hour around the black hole is 7 years on Earth. For every hour you are there, you are gaining 7 years on Earth. So when you come back, everybody is either dead or long gone because you spent so much time around a black hole. All right, I got one more scene I want to show you for black hole, or for Interstellar. Actually, I'm going to do that in the next movie, so hold on.